So this video is part 2 of adding probabilities. When we left off with part 1, I had asked you to go ahead and complete part B, given that there were 4 aces in a deck of cards. So probability of drawing an ace would be 4 out of 52. Then the probability of drawing a red would be 26 out of 52. To find the probability of ace or red, we would add the probabilities of A and R, but then subtract the probability of both. So the probability of ace was 4 out of 52. The probability of red was 26 out of 52. And then note that there are an ace of hearts and an ace of diamonds, both being red. And since they're both red, we have to subtract that out. So that's the probability of ace and red. There are 2 of them. So we subtract out the 2 out of 52. And that leaves us with a probability of 15 out of 52. So I hope you got that right. Next, we're going to do part C. It says the probability of a black or a spade. So think of your deck of cards. We know the probability of a card being black is half the deck, so 26 out of 52, while the probability of being a spade is 13 out of 52. But what we should note is there are 13 cards that are spades and black. So the probability of being black and spade is 13 out of 52. So you can pause it at this time and see if you can calculate this probability. So again, the probability here of black or spade is going to be the probability of being black plus the probability of being a spade minus the probability of being a black spade. And of course, all 13 spades are black. So 26 out of 52 are black, plus 13 out of 52 are spades, but there are 13 black spades. So we subtract that out, and we would just be left with 26 out of 52. Next, we're going to move on to looking at adding probability when we have a frequency table. So this is an instance where we're up here, for example, 2, where we just be stating, asking you to find some probability without any type of visual representation. Example 3 is a visual representation in the form of a frequency table, which we have been working with. Of course, to find any probability, we want to find our totals. So the total number of males is 45. The total number of females is 44. The total number who like chocolate are 59, and the total for vanilla 30, for an overall total of 89. And then when we are asked to find the probability of male or chocolate, so male or chocolate, are there any, by the way, that are male and chocolate? There are. And just like we did before, we have to be able to find that to be able to subtract it, because these 32 are going to be counted not only in the male total, but also in the chocolate total. So let's get started. The probability of choosing a male or chocolate would be the probability of male plus the probability of chocolate minus the probability of male and chocolate. So to get started, the probability of male, we'd want to know our male total. So that's 45 out of the 89 are male. The probability of chocolate, we want to know the chocolate total, and that would be 59. So 59 out of 89. But then we need to subtract the probability of male and chocolate. So male and chocolate, remember, and intersection, that's where they intersect. So there's 32 that that are male and like chocolate. 59 out of the 89. Or excuse me, 32 out of the 89. So you've got to subtract that out. So subtract out your 32 out of 89, and that leaves you with a probability of 72 out of 89. Next, for part B, I'm going to ignore that for now. We want to find the probability of female or chocolate. So if you would pause it at this time and see how you do with this one. So the probability of female, we want to use our female total, and that's 44 out of 89. To that, we want to add our probability of chocolate. Total chocolate is 59 out of 89. And then from that, we want to subtract the probability of female and chocolate. So female and chocolate, we look for the intersection on our table. That's 27 out of the 89. So subtract out 27 out of 89 to give you 76 out of 89.